Now our next problem. Find the volume of the solid generated when the region bound by the y-axis, y equals 4 and y equals 2x, is revolved about the y-axis. Now this one, there are two ways to do it. One is using what you know from geometry, and the other way is to use an integral. And I'm going to show you both ways. We'll start with the easy way. Okay, now if you can visualize what happens when this is rotated about the y-axis, we end up with a shape like this. This is, of course, a cone. Up here, we see that goes from here to here. That is length 2. Maybe a different color. This is length 2. And then the height here is 4. Okay? Now the volume of a cone generally is V equal to pi over 3 r squared h. Okay, so in this case, V is going to equal pi over 3 2 squared times 4. Okay, and now pretty easy. This is pi over 3, and then this is going to be 4 times 4, and 4 times 4 is, of course, 16. Maybe I'll just switch to black. And then pi over 3 times 16, the way you handle this is you put the 16 over 1. Pi times 16, that's 16 pi. 3 times 1 is 3. Okay, so that was the easy way. We'll just write 16 pi over 3 down here. Hopefully we get the same answer when we do it the hard way. This time we're going to do this problem using calculus. So let's say we have an arbitrary disk. It's going to be something like so. And then this goes back here, and I'll do that because it makes it more three-dimensional, hopefully. And this time, as you can see, our thickness is delta y. Okay. So now we have an issue because we need to find the radius here. Okay. Now you can see an arbitrary point. This is x, comma, y. And what's going to happen is that the radius here is x. However, we need to write x in terms of y. And the reason why is because we have delta y here, so when we change into an integral, it's going to be dy. Okay? But that's pretty easy to do. on this line, y is equal to 2x, which implies that x is equal to y over 2. Okay? Therefore, a little chunk of our volume, delta V, is going to be pi times y over 2 squared times, and of course this time, since the thickness here is vertical, it's going to be delta y. Now the square of y over 2 is y squared over 4, so we'll go ahead and write it like that. Okay, now pi times y squared over 4, we can put this over 1, and this is pi y squared over 4 delta y, and that is the same as delta v equal to pi over 4 y squared delta y. Okay, now that we have this, it converts to an integral as so. V equal to pi over 4 integral y squared dy. Alright, and now because this is dy, our bounds of integration need to be written in terms of y. Y goes from 0 to 4. And now we just use the power rule for integration. We add one of the powers, so that's going to be 3, and then we divide by the new power. Okay? And now it's just a matter of computation. Top minus bottom. So we have pi over 4, and then we have 4 cubed over 3 minus 0 cubed over 3. 4 cubed is 64. Okay. 0 cubed is 0. Any number divided by 0 divided by any number is simply 0. I'm going to, and then 64 over 3 minus 0 is 64. I'm going to drop the brackets. And then we have some cancellation here. 4 goes into 64 16 times. So we have pi over 1 times 16 over 3. Pi times 16 is simply 16 pi. 1 times 3 is, of course, 3. And you see here we got the same answer. For our last problem, we are going to find the volume of the solid generated when the region bound by the y-axis, y equals -2, and x equal 1 is rotated about y equal to -2. Now this is a little tricky because our radius changes. So this time we have a disk that looks something like the following. So note in particular that our radius is from here down to here. And the way kids usually approach this is they do top minus bottom. So in this case, R is going to equal the top, which is x squared, minus the bottom, which is -2. And x squared minus -2 is of course the same thing as x squared plus 2. Okay, and now that we've got that, it's pretty much the same. The thickness here is horizontal, so this is going to be delta x. Now we're ready to find our delta v. Delta v equal to pi r, which we just said was x squared plus 2, and then this sum here is squared, and of course times by our little bit of thickness, delta x. Delta v is equal to pi times the square of the sum of x squared and 2, all times delta x. Let's go ahead and expand this expression. Square the first, so that's x squared squared, twice the product, that's x squared times 2, which is 2x squared, and square the last, that's 2 squared, I'm going to switch to parentheses. X squared squared is the same as x to the 4th. 2x squared just comes right on down. And 2 squared is 4. Okay, so since delta v is equal to this, that implies that v is going to equal pi times the integral of x to the 4th plus 2x squared plus 4 dx. And since x goes from 0 to 1, we're going to put 0 down here and 1 up here. Let's take the antiderivative of each term. X to the 4th has an antiderivative of x to the 5th over 5. So we go ahead and write that here. Two x squared has an antiderivative of 2x cubed over 3. And the antiderivative of 4 is 4x. And this is from 0 to 1. I'm going to switch to parentheses again. 1 to the 5th over 5 is 1/5. One cubed is 1 times 2 is 2, and then divide by 3, that's going to be 2/3. And then 4 times 1 is 4. All of these terms, when you plug in 0, are 0, and when you add up zeros, you still get 0. So it's going to be this expression minus 0. Now anything minus 0 is just that thing, so this minus 0 is going to be this. I'm going to rewrite this in the next step. However, I'm going to do it with a common denominator of 15 so we can add the fractions. 1/5 is 3 over 15. 2/3 is 10 over 15. And 4 is, of course, 60 over 15. In parentheses. Okay. I'm going to go ahead and drop the parentheses entirely. 3 plus 10 plus 60 is 73. Therefore, this sum here turns into 73 over 15. And pi times 73 over 15, that's the same thing as pi over 1 times 73 over 16. And this multiplies to 73 pi over 15. All right, and that is our final answer. Thank you guys so much for watching. I hope you found this video helpful.